Last section in Chapter 6, we're going to talk about parametric equations. Parametric equations involve a parameter. And a parameter is often defined as a letter like t. So instead of having an equation with just an x and a y in it, we're now going to have two equations to represent a line. And both equations will be in terms of t. Now, the reason why parametric equations are used is for a couple reasons. One reason is that it allows you to draw functions or curves that are not functions. For example, it can draw a line that for each x it has two y's, whereas regular function mode, Cartesian mode, you can only have one y for each x. So that's one reason why we have parametric equations. Another reason why we have parametric equations is because it makes more sense in some story problems. For example, if a lot of times parametrics are in terms of t, and t can represent time. So you can draw things based on time that have two things going on instead of one thing going on. For example, you could track the path of a ball because you could have the x-coordinate in terms of t, time, and the y-coordinate in terms of time, t. Whereas a regular equation, you couldn't have that element t in terms of two different parts of that equation. So what I want to do today is basically look at parametric equations, how we use them in a graphing calculator, what they look like, how do you transform parametric equations into Cartesian equations. How do you go from two equations with an x, y in it, and in terms of t, and convert that into one equation with only an x and a y, and get rid of the t. First thing that I want to do is remind you that we're going to have three Pythagorean theorem identities for trig, and those should be in your big rock sheet. They're starting with the sine squared plus cosine squared equals 1, and then you can divide out the cosines and divide out the sines, and you'll end up with the next two equations. So we've had those two equations. We're now going to work with these equations. Once we get into the problems, you're going to see I want to start with one of these three. So you want to put those in a box, star them. That's where you're going to be your go-to in this problem. And if you start with those, the rest of it's going to be easy. All right, let's go back to talking about how we graph parametric equations in the graphing calculator. So what I want to do is go to your graphing calculator, and in your graphing calculator, you want to go to the mode button. Again, the mode button is the button that is going to be your setup of the calculator. And as you go through, you're going to see radians. I want to be in radians. You could also do degrees, but it's probably a good idea to start getting more comfortable with radians, since calculus will be in radians. And functions, the second button over will be parametric equation. Instead of function mode, we have parametric mode. Also on that line, you're going to have polar mode, which we're going to get to in this book, and sequential mode, which you can identify an equation based on the previous equation, so it can be a recursive equation. And that's how you can graph that one. So there are different ways that you can use your calculator in graphing different types of equations. So now watch what happens when I go to y equals. You're going to see that I'm going to have an x sub 1, y sub 1. Your calculator will automatically adjust to a parametric mode. these two equations here are going to be in terms of one graph. You're going to get an x coordinate by plugging in t, and you're going to get a y coordinate in plugging in t, and that xy coordinate is what's going to go onto the graph to plot. And then as you circle through all of your t's, you're going to be generating all these xy points, and that's what's going to be plotted on that graph. But you can see that your t now is going to be the independent variable, and your dependent variable is going to be your xy. All right, if I left this the way it is, I'm just going to think about this. My x's are going to be my t, my y's are going to be the sine t. So this should, if you think about your xy points, x's are t, y's are sine t, it's really the same xy, like y equals sine x. It's the same graph as what I'm showing here, because your x's are t and your y's are going to be the sine t. So I want to graph this, and again I go to Windows, and look what happens in your Windows button. It automatically gives you a prompt for your t's, because you have to know what your t's are getting substituted in for those two equations. Well, you have to understand what your t represents in the problem. In this case, t is going to represent numbers between 0 and 2 pi, because I want to draw all the ones in the unit circle, all one revolution. So I'm looking at 0 to 2 pi, and then I need a step, which is going to be somewhere between 0 and 2 pi. The step means draw a point at each of these steps along the way. If I were to make this 6.2, I'm only going to be drawing 1 point at that 6.2. But I want to draw a lot of points along the way, so I get a good representation of what the curve looks like. And then you have an x-min and an x-max. Those are basically going to be the same x and y's that you're talking about, the width of the screen, the height of the screen. So I can just say, all right, I'm just going to do my x-min at -2, my x-max at 2, x-scale somewhere between -2 and 2. That just puts the dots in. And y-min, I'll say -2 and y-max 2, because I know that this is going to graph that sine graph. So when you go ahead and graph this, I made a mistake in terms of what I want to see on that graph. I want to see the sine graph. I don't want to see my x and y. So let me back up to my window and think a little bit more clearly on this. My x-min should be more like -0.1. My x-max should be 2 pi. And then my x's are going to go from 0 to 2 pi, which are the same thing as my t's. Okay, that's fine. My y's are going to go from -2 to 2. That should be fine. And now when I go ahead and graph that, hopefully it gives me a better graph. So there's my sine graph. One cycle of the sine graph. It's the same thing as what I did before. That's not too different, but it's in parametric mode. What does it really mean? Well, when I hit trace and go to the right a couple times, you can see now that the calculator has different things that are prompting you on the screen. It's showing you that based on your t, which is your angle, it's giving you what your x is and what your y is. And it's also showing you what your equations are for your x and your y. So based on your t, it's delivering you an x value and a y value, and that's what it's plotting on that graph. All right, Well, why do we want to use this? There's other things that you can graph, such as if I put in cosine t here. Now, if I put a cosine t there, I'm going to have my x yielding all of my cosine values and my y yielding all my sine values, which means that a cosine graph goes from -1 to 1, a sine graph goes from -1 to 1. So you know what your x and y fields should be, right? I'm no longer talking from 0 to 2 pi for my x's and y's. I want from -1 to 1. So I'm going to go to the windows and change that a little bit. My t's, I still want between 0 and 2 pi because that's my angles that I'm going through. But my max, my y min, and my y max, I now am going to be doing it a little bit more than -1, or a little bit bigger negative number than -1. And then I want a little bit larger number than 1. And I want to do the same thing for the y min and the y max. And now I should see when I graph that it's going to give me some sort of ellipse. Or is it an ellipse? It looks like an ellipse, but when I trace this, look what's happening as I go to the right. What does that mean again? It means that as your t go through your radians, you're getting an x, which is a cosine of an angle, and a y that is a sine of an angle. When you think about the x and the y, x is cosine, y is sine, that should trigger something in your mind that you've seen before, hopefully, and that would be the unit circle. The unit circle has cosine as x's, sines as y. So what we just did is we produced the unit circle. Notice it's not a function. We couldn't graph this in function mode. If you look at the vertical line test, it's not going to pass it. So you're going to see that it's actually drawing the unit circle, but it's not a unit circle because it's an ellipse or it's an oval. And so something must be going wrong. What's wrong is this. This is a rectangular screen, so when you go the same distance on your positive x to your positive y, this spacing from 0 to 10 is going to be wider than this spacing from 0 to 10, right? From 0 to 1 is more than from that 0 to 1. And that's why it's drawing an ellipse, because you're doing the same distance. You can show the same distance on the right to the up side of this graph by making it square. How do you make it square? I can go to zoom and hit the square button, zoom square, which is number 5. You don't use that too often. And now the spacing is actually going to be the same exact spacing, and that's going to create the circle. So there are reasons why your calculator is doing things, and this ends up being a 3-to-2 ratio on the spacing of those. So when you go back to Windows, you should see that your x min and y, the scales for your y and your x's should be in a ratio of 3-to-2. All right, so that's a parametric equation. That's what it's used for, one of the purposes. And I'm not going to test you on the graphing part of it. I just wanted to give you a background on the unit circle. And so now what we're going to do is go back to the bookwork and work a little bit more with the parametric equations. And you know that there's a parametric mode and there's a function mode. And so what I want to do is change from parametric mode to function mode. Now, before I forget, what you may want to do is on your graphing calculator, go back to the function mode, because you may need that function mode later and you may forget what you just did there. So you may want to replace it after you're done with the parametric. Going back to the book work, what we're going to focus on is actually transforming the parametric equations into a function equation. In other words, what I want to focus on is eliminating the parameter t. The way to eliminate the parameter t is to start with an identity and substitute in values, and once you do that, you're pretty much done. Now, the book is going to also have you do that, and also have you name the different conic sections, like is it a circle, is it an ellipse, is it a hyperbola, is it a parabola? And then it's going to have you draw that. Well, if we were to have you do that, we've got to go back and study those conic sections first, and then we have to be able to name them based on this, and that's going to take another probably week. So we are not going to be doing the graphing portion of this section. The only part that you're going to have for homework, regardless of the directions, is to simply convert from one equation to the other equation. So keep that in mind when you're reading the directions and doing your homework. So back to this, what we're going to do is we're going to do a substitution and start with these identities. All right. The problems are going to look something like this. This is number 14. It says x is equal to 4 sine t minus 5, and y is equal to 4 cosine t minus 5. Notice you have a parameter t in those equations, just like we did when we drew the unit circle. The directions are basically get rid of that t and only have one equation with an x and y in it. That's it. Get rid of the t, only have one equation with x and y, and then you're done. And these are very easy. So what you're going to notice is that you have sines and cosines. I want to start with the identity with sines and cosines. So I write that identity down. Sine t squared plus cosine squared t squared is equal to 1. Start with the identity and then somehow substitute into that identity. What are you going to substitute in? Well, on this equation right here, I know that that's equal to, let's see, sine t is what I solved for. So to get sine t, I'm going to add 5 and divide by 4. When I add 5, I get x plus 5 divided by 4 is x plus 5 divided by 4 is equal to sine t. And if I did the same thing on this one, I'm going to see solving for cosine t. I add 3 and divide by 4. Now, these are easy problems. You may want to do that in a couple steps just to make sure that you don't make a mistake on a negative sign, because if you make a mistake on the negative sign, it's really hard to give you partial credit on these because there's so little that you're doing. At this point, you're just substituting in for sine t and substituting in for cosine t. So what do you get? X plus 5 over 4 squared plus y plus 3 over 4 squared is equal to 1. You just changed these two equations into one equation, and there's no parameter t, so you're basically done with that. Now, the book is going to have different forms in the solutions, because depending upon if it's a circle, parabola, ellipse, or hyperbola, it's going to require a certain form to look at. You don't know those forms at this point, or you may have studied them last year, but as far as I'm concerned, I'm good with that right there. You don't have to go any further. But just so you know, if you were to continue this, you'd get x plus 5 squared over 16 plus y plus 3 squared. And if I multiplied both sides by 16, what I really get is this form of this particular equation. And that form you may have seen before as a form of a circle. It's that same thing that you've studied. It's x minus h quantity squared plus y minus k quantity squared equals r squared. It follows that circular form, and that's why it's written like that in the back of the book. But again, you don't have to get into that. You don't have to draw. The main thing I want is that substitution. One more problem we're going to be looking at is number 20, and you're just going to see that instead of sines and cosines, you're dealing with tangents and secants. First thing I'm going to do is start with the identity again. Well, let's say that you don't remember what that identity is. You could start with sine squared plus cosine squared equals 1 and then find that identity. So why don't I just do that, assuming that you don't remember what the other one is. So I'm just going to do, all right, cosine squared plus sine squared equals 1 in shorthand. And I want a tangent. How do I get a tangent? I'm going to take sine over cosine. So I'm going to divide both sides by cosine squared. This becomes 1 plus tangent squared equals secant squared. And there's my identity that I want to use. All right, so I'm starting with this identity. And now I just want to, again, do the same exact thing that I did before. I want to solve for tangent. So it's going to be x minus 3 divided by 5 equals tangent t. And I want to solve for secant. Y minus 2 divided by 5 equals secant t. At this point, we're going to do the substitution. 1 plus you can see that form is going to be a little bit different than the other form because you have a 1 over here and it'd be y squares minus x squares. So that's going to be actually in the form of a hyperbola. So this is, again, you're going to stop right here. I'm totally fine with leaving it like that, and you're done. This should be easy section to work with. You should not get these problems wrong. They should be even easy points. So do them, be accurate with them, but you want to spend time more on the other problems on the test.